With Doubtnut, get instant video solutions to all your maths, physics, chemistry, and biology doubts. Just click the image of the question, crop the question, and get instant video solution. Download Doubtnut app today.
Hello everyone, let us try to solve the given problem, right? So the given problem says that a small spherical monoatomic ideal gas bubble. So we can see a bubble here. It is trapped inside this liquid of density rho L. Assume that the bubble doesn't exchange any heat with the liquid, right? So this bubble is not exchanging any heat with its surrounding, which simply means an adiabatic process. The bubble contains n mole of a gas. The temperature of the gas when the bubble is at the bottom is T0. So this bubble must have been at the bottom at some point and then its temperature was T0. The height of the liquid is capital H and the atmospheric pressure is P0. Then when the gas bubble is at height Y from the bottom, its temperature is. Now when this gas bubble is at height Y, then we have to find what will be its temperature. You can see here when this gas bubble comes from here to here, right? So its temperature and pressure will change, and that change will be simply adiabatic. Why? Because this bubble is not exchanging any heat with its surrounding, so that will be an adiabatic change. So how do we find out the temperature? Here is suppose that T0 at the bottom, and how do we find out the temperature here? Let us say T2, and let us take this as T1 equals to T0. So how do we find out the temperature here? So pressure here will be different because you can see that the pressure in the liquid column is different at different heights. So pressure here, let's say, will be P1, and the pressure here, let's say, will be P2, right? So this, when this bubbles comes upward, so this will be an adiabatic change. Why? Because there is no heat transfer. So how do we find out the temperature T2? Since this is an adiabatic process, so this will be equals to T1 times P1 divided by P2 to the power 1 minus gamma divided by gamma. Now how do we write P1? So P1 is the pressure at the bottom. So how do we write P1? T1 we already know, we have written T1 is equals to T0, and we have to find the answer in terms of T0. So let's first find P1. So how do we write P1? Now P1 will be simply equals pressure at this depth will be simply equals to the pressure, atmospheric pressure here, plus rho L. Rho L is the density of this liquid into G into total height H. So this is P1. Similarly, how do we write P2? P2 is the pressure at this depth. So what is this depth? The total depth is H and this is Y. So depth up to this bubble will be simply equals to pressure at 2 will be simply equals to atmospheric pressure plus density of the liquid G into here the depth will be H minus Y, because we can clearly see that this is at the depth H minus Y, right? Now we know the P1, we know the P2. Now we also know the gamma. Value of gamma is given in the question. This is equals to 5 by 3. So we simply need to substitute that and find out the correct equation, right? So let's try to find out. So this will be equals to T2 will be equals to T0. Now P1 is simply P0 plus density of the liquid GH divided by P0 plus density of the liquid G H minus Y to the power 1 minus 5 by 3 divided by 5 by 3. Now when you solve this, what you are going to get? You are going to get T2 equals T0. You can take the LCM here, 3 minus 5. So this is 2 by 3 and this is 5 by 3. So this will get cancelled. So this is P0 plus rho L G H divided by P0 plus rho L G H minus Y. So this will be simply equals to minus 2 divided by 5, because in the numerator it will be minus 2 by 3 and in the denominator it will be 5 by 3. So 3 will get cancels from the denominators and this will be minus 2 by 5. So now we can, since this is a negative, so we can reverse this and we can write it in this form. So T2 will be simply equals to T0 into, to make this positive, we can write P0 plus rho L G H minus Y divided by P naught plus rho L G H to the power plus 2 by 5. So let's try to match our options, right? So which options matches with our answers? I think the B matches with our answers. I hope you understood the explanation. Thank you.
For class 6 to 12, IIT JEE and NEET level. Trusted by more than 5 crore students. Download Doubtnut app today.